This protocol outlines the operation strategy to detect, engage, and neutralize unidentified aerial phenomena, UAPs, utilizing the neutrino detection and electromagnetic pulse EMP interception systems. This strategy is implemented due to reports suggesting UAPs utilize space folding mechanisms and materialize into our observable universe, often cloaked behind satellites to maintain stealth. Neutrino detection. The neutrino detection grid located in Antarctica is the primary early warning system. Upon detecting an influx of neutrinos indicative of UAP materialization, ground operators will alert the satellite network. This grid operates on a principle of advanced particle physics, allowing the system to predict UAP emergence points now. Upon receiving alerts from the neutrino detection grid, the satellite network shifts focus to the designated areas. All satellites are equipped with neutrino trackers and EMPs. Particular attention is given to the satellite directly obstructing our view of the emerging UAP, providing a blind spot for the phenomenon. Electromagnetic pulse interception. After determining the UAP's line of sight, the obstructing satellite targets the area and discharges an EMP blast along the predicted trajectory. This preemptive strike does not require exact distance calculations, as the blast radiates along the entire line of sight, ensuring interception. The resultant electromagnetic disturbance forces the UAP into low Earth orbit, potentially causing disorientation and structural damage. Should the UAP sustain considerable damage, standard military aircraft could be utilized for interception. Now, optional engagement tools. Depending on the specific scenario, alternative engagement tools such as railguns, lasers, or neutrino-based weaponry can be used in place of EMPs. However, EMPs are generally considered the most effective given their ability to disorient the UAP and force it into a lower altitude. The resultant descent of the UAP will typically lead to either a forced landing or a crash, providing an opportunity for recovery and analysis.
This protocol leverages cutting-edge technology to counteract the superior tech exhibited by UAPs.
By predicting their emergence point and intercepting them in their blind spots, we are effectively nullifying their advantages, thus leveling the playing field. This document is classified top secret/special intelligence and should be handled according to established security protocols. Unauthorized distribution of this document can result in severe penalties. And document. Top secret, special intelligence. Project Pulsar Storm. Watton-Potten pressure. Send up back device.
This document outlines the observed strategy utilized by unidentified aerial phenomena, UAPs, as they materialize into our observable universe.
The outlined strategy plays a significant role in the planning and execution of our interception protocols, as outlined in the Neutrino MPUAP Interception Protocol document. Emergence. UAPs seemingly employ space folding mechanism to enter our observable space-time. This process triggers a detectable neutrino signature, providing our early warning systems with an alert to their presence. However, UAPs have demonstrated a method to emerge directly behind our satellites, exploiting a blind spot and concealing their entrance. Our interception protocols counter this advantage by detecting the neutrino signature and effectively predicting their emergence point, surprising them in turn. And then reaction to EMP interception. Upon emergence and immediate detection, our protocols dictate the deployment of an EMP blast, creating disorientation and possible damage. This unexpected retaliation likely causes further surprise to the UAP, forcing it to descend to a lower altitude to regain control.
As the UAP descends, either disoriented or damaged, our protocols call for immediate close-range engagement.
The appearance of a fighter jet or reverse-engineered craft at such proximity likely catches the UAP by further surprise, as it was not expecting immediate retaliation upon its forced descent. And the UAP strategy relies heavily on the element of surprise and an assumption of technological superiority. And our interception protocols effectively counteract these advantages, utilizing our understanding of their emergence strategy and immediate reactionary tactics to neutralize potential threats. This method of double surprise effectively puts the UAP at a significant disadvantage despite their advanced technological capabilities. This document is classified top secret / special intelligence and should be handled according to established security protocols. Unauthorized distribution of this document can result in severe penalties. And document, undisclosed. It is classification, top secret, special intelligence, no foreign nationals, that will employment of ionization barrier for UAP. This highly classified document pertains to an additional level of interception protocol employed for unidentified aerial phenomena UAPs, codenamed Aurora Shield. Introduction. This stage of the protocol is activated following EMP disruption and involves the use of HARC stations to create an ionization barrier. Ionization barrier technique, the High Frequency Active Auroral Research Program, HAARP stations, are utilized to ionize a projected descent path of the UAP post-EMP disruption. This ionization effectively creates a physical barrier or force field in the airspace which the descending UAP encounters.
The LP impact and damage. The suspected collision with the ionized barrier results in significant damage to the UAP, depending on the prevailing atmospheric conditions of the ionization area.
Specific conditions can increase the solidity of the ionization barrier, resulting in a more severe impact. Post-impact engagement. Upon collision with the ionization barrier, the UAP is often further disoriented and damaged, rendering it susceptible to standard fighter jet engagement. In this compromised state, the need for a reverse-engineered craft to facilitate forced landing or takedown is typically not necessary. Conclusion: the Aurora Shield protocol complements the existing Neutrino EMP UAP interception protocol and the UAP emergence and engagement strategy assessment in effectively neutralizing potential UAP threats. This tri-level approach ensures we can effectively respond to UAP incidents regardless of their technological capabilities and the element of surprise they utilize. And distribution. This document is classified top secret, special intelligence, no foreign nationals, and is subject to strict distribution protocols. Unauthorized distribution or dissemination of this document to foreign nationals, including allies, is prohibited and may result in severe penalties. End document. Direct Emergence Protocol, DEP. Introduction. This protocol outlines the operation strategy to detect, engage, and neutralize unidentified aerial phenomena. Do not utilize satellites for cover during materialization into our observable universe. The Aurora Pulsar Storm protocol is comprehensive and robust. However, by adapting the DEP protocol and incorporating a ground scanning system using sky-based neutrino detectors will provide an additional layer of early detection and tracking. Ground scanning neutrino detection. In addition to our space-based sensors, a sky-based neutrino detection system will be incorporated into the early warning system. The primary purpose of this system will be to monitor neutrino emissions from Earth's surface and atmosphere, indicative of UAP materialization. The neutrino detection system will be placed aboard satellites and will operate in concert with the ground-based neutrino detection grid. And so the system will utilize advanced particle physics principles, allowing it to predict UAP emergence points in the absence of satellite cover. Upon detecting an influx of neutrinos from the ground, the sky-based neutrino detection system will alert the satellite network and the ground-based early warning system. This ensures a swift and coordinated response to the emergence of UAPs, regardless of their point of origin. With this dual-layered neutrino detection system, we can effectively detect UAPs, whether they materialize in the sky or near the ground, giving us a significant advantage in early detection and response. This makes our protocol more robust and adaptable to different UAP emergence scenarios. And as with the rest of the direct emergence protocol, the ground scanning neutrino detection system should be flexible and adaptable, allowing for swift changes in strategy depending on the specifics of the UAP encounter. Enhanced early detection. Since these UAPs do not use satellites as cover, they may be detected earlier by our enhanced early warning system. So this system will incorporate a global network of highly sensitive gravimeters to detect gravitational anomalies and a multi-spectrum sensor network to detect UAPs across various electromagnetic spectra. This could increase the chance of detecting UAPs regardless of their stealth capabilities, space-based detection, and tracking. We also employ a constellation of space-based sensors equipped with AI-assisted tracking systems. These sensors will detect any changes in the cosmic background radiation, gravitational waves, or other anomalies that may indicate the presence of a UAP. EMP intersection. Upon detecting a UAP, the closest satellite will target the UAP and discharge an EMP along its predicted trajectory. In this scenario, depending on the altitude and proximity to human-occupied zones, an EMP may not be a viable choice. And the alternative engagement tools. If the EMP does not achieve the desired effect or cannot be deployed, alternative engagement tools such as railguns, lasers, or neutrino-based weaponry should be deployed. The choice of weaponry should be determined based on the specifics of the UAP's behavior and trajectory. Ionization barrier technique. Simultaneously with the EMP or alternative engagement tools, arc stations will project an ionization barrier in the path of the UAP. This will serve as a secondary disruption technique, causing further disorientation and potential structural damage. Enragement phase. Once the UAP is disoriented and potentially damaged, it becomes a viable target for further engagement. Depending on, the level of damage inflicted, either standard military aircraft or reverse engineered craft are deployed for close range engagement. Recovery. The resultant descent of the UAP will typically lead to either a forced landing or a crash, providing an opportunity for recovery and analysis. Rapid response teams trained in handling such situations and equipped with technology capable of containing potential hazards associated with UAPs should be deployed immediately. Conclusion. This protocol leverages cutting-edge technology and a flexible multi-pronged approach to neutralize UAPs that do not utilize satellites for cover by using a combination of early detection systems, disruption techniques, and engagement tactics. We can effectively respond to these UAP incidents. Remember, in this scenario, the UAP may have a different behavior pattern since it does not use a satellite for cover. And therefore, adaptability and rapid decision-making will be key in regards to the current RRA Pulsar Storm Protocol. I can make the following observations and suggestions. The current interception protocols appear to be well thought out and utilize cutting-edge technology, but there's always room for improvement and additional layers of security. So the main aim should be to add more redundancy and variability in the response to the UAP emergence. Here are a few suggestions. Enhanced early warning system. While the neutrino detection grid is an excellent early warning system, it might be worthwhile to explore additional methods of early detection. And for instance, if the UAPs are using a space folding mechanism, there might be gravitational anomalies that could be detected. A network of highly sensitive gravimeters stationed at various points around the globe could potentially provide an additional layer of early warning. Redundant EMP deployment. Instead of relying on a single satellite to discharge the EMP blast, consider deploying multiple EMPs from several satellites, and this could increase the chance of successful disruption of the UAP. Advanced AI tracking system. Implement an advanced AI system that can predict the UAP's trajectory based on initial data. This could provide more accurate targeting information for the EMPs and subsequent engagement forces. Multi-spectrum sensor network. Create a sensor network that can detect UAPs across various electromagnetic spectra. This could help in detecting UAPs even if they have stealth capabilities in certain spectra. Additional engagement method. Consider developing alternative methods of engagement that can be used in the event that the EMP disruption and Aurora Shield protocols are ineffective. These could include non-lethal methods aimed at disabling the UAP, such as directed energy weapons that can disrupt the UAP's control systems. Improved containment and recovery. If a UAP is forced to land or crashes, the containment and recovery phase is critical. Develop rapid response teams trained in handling such situations and equipped with technology capable of containing potential hazards associated with UAPs. Moreover, recovery should be done with the intent of minimizing potential damage to the UAP for further study. Protocol variability. Incorporate more variability into the interception protocol. The current plan seems to follow a linear progression, neutrino detection, EMP deployment, Aurora Shield close engagement recovery. Consider developing a decision tree or flowchart based protocol that allows for greater flexibility based on the specifics of the UAP encounter. This variability can increase the unpredictability of the response, potentially confounding UAP strategies. International cooperation. Despite the classification of the documents, international cooperation may be beneficial for a more comprehensive early warning and response system. While the specifics of the technology protocols can remain classified, a global UAP tracking system could provide additional data and increase the chance of successful interception. Remember, the key to a successful interception protocol is flexibility, redundancy, and unpredictability. The more options you have at your disposal, the more likely you are to successfully neutralize a UAP. The UAP warning and non-aggression assurance protocol, we've got to borrow armed introduction. While the defense of our airspace remains paramount, we recognize the potential risks of preemptive strikes, particularly against non-hostile UAPs. To mitigate these risks and uphold a posture of non-aggression, we propose the UAP warning and non-aggression assurance protocol. This protocol outlines steps to issue warnings to UAPs and attempts to establish a communication channel to assure non-hostile intentions. UAP warning system. Given the advanced nature of UAP technology, conventional warning systems may be ineffective. We propose a system utilizing space-based neutrino emitters to project a warning field around our planet. This field will emit a constant stream of neutrinos carrying a simple, repeating signal designed to be universally recognizable as a warning. Manipulation. The constant neutrino flux from this field should be detectable by any technologically advanced species capable of space folding and neutrino manipulation. Communication attempts. Simultaneously, we propose an effort to establish communication with the UAPs utilizing the same neutrino-based technology. Neutrinos, being weakly interacting particles, can pass through almost all forms of matter, making them an ideal medium for interstellar communication. The message should be simple and universal, indicating our planet and our desire for peaceful coexistence. Escalation protocol. Escalation. The UAP ignores the warning field and proceeds to violate our airspace. We will follow an escalation protocol before resorting to direct action. This will involve increasing the intensity of the neutrino warning field and trying to communicate more directly with the UAP. So if these efforts fail and the UAP continues to approach, we will implement the engagement protocols outlined in the Neutrino IMP, UAP interception protocol, the UAP emergence and engagement strategy assessment, and the Aurora Shield. While the defense of our airspace and the security of our planet are paramount, we must strive to balance these requirements with the desire for peaceful coexistence. The UAP warning and non-aggression assurance protocol represents an attempt to achieve this balance, offering a warning and opening a line of communication before resorting to direct action. It is our hope that this protocol will help prevent unnecessary aggression, promote understanding, and foster peaceful relations with any extraterrestrial civilizations we may encounter. However, entering our airspace behind a satellite for cover should always be interpreted as a hostile maneuver and treated as such. The same would apply to known hostile NHIs. Further suggestions. In principle, the Starlink satellite network could be adapted for this purpose, but it would require significant modifications and enhancements. Neutrino detection is a complex task that typically requires very sensitive and specialized equipment. Neutrino detectors on Earth, such as those at the IceCube Neutrino Observatory in Antarctica, are massive installations that take advantage of large volumes of dense material, in IceCube's case a cubic kilometer of Antarctic ice, to increase the chance of neutrino interaction. Neutrinos are known for their weak interaction with matter, meaning they can pass through almost anything without being affected. This makes detecting them extremely difficult. Neutrino about adapting the Starlink satellites for neutrino detection would likely involve equipping them with miniaturized neutrino detectors, which are a significant technological challenge. As of my knowledge cut off in September 2021, such technology did not exist, and the development of space-capable neutrino detectors would likely require significant advancements in particle detection technology and miniaturization. And furthermore, the satellites would also need additional shielding and power supply enhancements to accommodate the additional hardware. Aside from the technological challenges, there would be logistical and bureaucratic hurdles to clear as well. The Starlink network is a private enterprise owned by SpaceX, so any adaptations for military or defense purposes would likely require complex negotiations and agreements or even legislative changes. However, if these challenges can be overcome, a network of neutrino detecting satellites like Starlink would provide a powerful tool for detecting UAPs or other anomalies in space. The sheer number of satellites in the Starlink constellation would provide excellent coverage and redundancy. The system would also benefit from being space-based, eliminating the need to account for atmospheric interference and neutrino detection. In conclusion, while adapting the Starlink network for neutrino scanning is theoretically possible, it would be a major undertaking requiring significant advancements in technology and changes in policy. And potential benefits, though, could be substantial in lunar neutrino monitoring station. Assuming that technological limitations are not a significant concern, and we have access to advanced, as yet unreleased technology, placing a neutrino detector on the moon to monitor Earth could provide a number of benefits.
Benefits: broad coverage. Given the moon's distance from Earth, a lunar-based neutrino detector could effectively cover the entire planet, providing global monitoring capabilities. Minimized interference.
The lack of an atmosphere and significantly reduced seismic activity on the moon would mean fewer sources of interference, leading to cleaner data and potentially more accurate detections. Constant monitoring. Unlike Earth-based detectors, which may have to contend with varying conditions and periods of downtime, a lunar detector could function continuously, providing 24/7 monitoring. And assuming advanced technology, the following steps could be involved in establishing a lunar neutrino detector. Lunar installation, using advanced robotics, and perhaps even in situ resource utilization. All ISRU, neutrino detection facility, could be established on the lunar surface. This could involve building an underground detector to minimize exposure to cosmic radiation, or perhaps even the use of advanced materials or force fields to achieve the same effect. Data transmission. The lunar neutrino detector would need a reliable way to transmit data back to Earth. This could be achieved through a dedicated communications array, perhaps utilizing quantum communication technology for secure instantaneous data transmission. Integration with Earth-based systems. The data from the lunar detector would need to be integrated with data from terrestrial and satellite-based systems to create a comprehensive picture of UAP activity. This could be facilitated by advanced AI systems capable of analyzing and correlating vast amounts of data in real time. The additional data from the lunar neutrino detector response to detected UAPs could be faster and more accurate. This could include the activation of the previously mentioned protocols, or perhaps even the deployment of space-based countermeasures if the technology allows for it. This advanced scenario assumes not only significant technological breakthroughs, but also political will and international cooperation, as the moon is considered a global commons. However, if these conditions are met, a lunar neutrino detector could greatly enhance our ability to detect and respond to UAPs. The development of a firing trap system for the interception of unidentified flying objects. Introduction. Unidentified flying objects, UFOs, have been a source of fascination and intrigue for many decades, with numerous reports of their sightings around the world. However, despite the numerous accounts, the nature and origin of these objects remain a mystery. In light of the growing number of sightings, it is crucial that the military establish an efficient and effective means of detecting and intercepting these objects. To this end, this paper proposes the development of a firing trap system for the interception of UFOs. Rationale for a firing trap system. The use of a firing trap system offers several advantages over traditional methods of interception. Firstly, the firing trap system can be designed to be fully automated, making it less reliant on human operators who are prone to error and bias. Secondly, a firing trap system can be easily integrated into existing radar systems and air defense networks, allowing for seamless integration into the existing infrastructure. Thirdly, The use of a firing trap system can help to reduce the risks associated with traditional methods of interception, such as aircraft interceptors, as it eliminates the need for manned aircraft to approach and engage with the target. The design of the firing trap system must take into account several important factors, including the speed and trajectory of the UFO, as well as its altitude and composition. And additionally, the system must be able to distinguish between a UFO and other air traffic, such as commercial or military aircraft, to prevent accidental engagements. To this end, the system will incorporate a range of sensors and advanced algorithms to accurately track and identify the UFO and to determine the appropriate course of action. The firing trap system will consist of a combination of ground-based radar systems and air-to-air missiles. The ground-based radar system will be responsible for detecting the UFO and determining its speed, altitude, and trajectory. The air-to-air missiles will be equipped with guidance systems that allow them to home in on the target and intercept it. And the firing trap system will be programmed to launch the missiles as soon as the UFO is within range, ensuring that it is intercepted before it can escape. Implementation and deployment. The implementation and deployment of the firing trap system will require significant investment in research and development, as well as the establishment of a dedicated team of experts from a range of fields, including engineering, physics, and computer science. Additionally, the system will require significant modifications to existing radar systems and air defense networks to ensure seamless integration and optimal performance. In terms of deployment, the firing trap system will be installed at strategic locations around the world, with a focus on areas with high levels of UFO activity. This will allow for rapid and efficient interception of UFOs wherever they may appear. Additionally, the system will be designed to be modular and scalable, allowing for easy expansion as the need arises. Standard munition firing for choreographed destruction of UFOs. The use of standard munition firing to choreograph the destruction of unidentified flying objects is a critical aspect of the firing trap design. The concept involves using a combination of ground-based weapons and airborne weapons to engage and destroy the UFO. Ground-based weapons play a vital role in this process as they serve as the initial line of defense against the incoming UFO. Weapons such as high-powered lasers will be used to engage the UFO and create a path for airborne weapons to follow. And by utilizing the power of these lasers, the UFO will be forced to alter its course, making it easier for the airborne weapons to engage it. Airborne weapons, such as missiles, will then be used to deliver the final blow to the UFO. And the missiles will be equipped with advanced guidance systems that allow them to follow the path set by the ground-based weapons. This allows the missiles to precisely target the UFO, ensuring that it will be destroyed with minimal collateral damage. In order to choreograph the destruction of the UFO, the ground-based weapons and airborne weapons will need to be coordinated and synchronized. The timing of the laser engagement, the speed of the missiles, and the altitude of the aircraft carrying the missiles will all play a crucial role in this process. And choreographed destruction of the UFO will be achieved through a combination of advanced sensors, communication systems, and control systems. So sensors will be used to detect the incoming UFO, and the communication systems will be used to transmit this information to the control systems. In turn, will be used to coordinate the engagement of the ground-based weapons and airborne weapons, the use of railguns and 50 caliber machine guns in the UFO firing trap system. In addition to the standard munitions firing system, railguns and 50 caliber machine guns can also be employed to corral the UFO into the path of the missiles. CARA. The high velocity and accuracy of railguns, combined with their rapid fire capabilities, make them an ideal weapon for directing and controlling the flight path of the UFO. The 50 caliber machine guns, on the other hand, provide a complementary role, offering a quick and accurate means of making course corrections or applying additional pressure to the UFO as needed. The railguns would be placed at strategic positions around the perimeter of the UFO firing trap system, with the aim of maintaining a consistent barrage of high-speed projectiles towards the UFO. The railguns could be controlled remotely or integrated with the system's overall command and control network, allowing for real-time adjustments and fine-tuning of the firing trajectory. This would ensure that the UFO is consistently directed towards the path of the incoming missiles, even in the face of evasive maneuvering by the UFO. The 50 caliber machine guns would provide a secondary layer of control, allowing for rapid adjustments and real-time course corrections. These weapons could be deployed in a similar fashion to the railguns, with multiple positions located around the perimeter of the UFO firing track system. The machine guns could be fired in short bursts, allowing for precise adjustments to the UFO's flight path and preventing any deviations that may occur during the engagement. By combining the high velocity and accuracy of the railguns with the rapid fire capabilities of the 50 caliber machine guns, the UFO firing trap system will have the ability to corral the UFO into the path of the missiles with a high degree of precision. This will increase the chances of successful intercepts, reducing the risk of UFO incursions and ensuring the safety and security of our airspace. The integration of railguns and 50 caliber machine guns into the UFO firing trap system will provide a multi-layered and highly effective means of controlling and directing the flight path of the UFO. This will enhance the overall efficiency and effectiveness of the system, increasing the likelihood of successful intercepts and safeguarding our airspace against the threat of UFO incursions. The standard munition firing approach to the destruction of UFOs presents a highly effective solution for defending against this potential threat. By utilizing a combination of ground-based weapons and airborne weapons, it is possible to choreograph a destruction of the UFO, minimizing the risk of collateral damage and ensuring that the UFO will be destroyed in a timely and efficient manner. The combination of advanced sensors, communication systems, and control systems will ensure that the weapons are precisely targeted, maximizing the chances of a successful engagement. The development of a firing trap system for the interception of UFOs offers several advantages over traditional methods of interception. And the system will be fully automated, integrated with existing radar systems and air defense networks, and designed to reduce the risks associated with traditional methods. The implementation and deployment of the system will require a significant investment in research and development, as well as the establishment of a dedicated team of experts. The end result will be a highly effective and efficient system for the intersection of UFOs, which will play a vital role in maintaining the safety and security of our planet. In this final section, we will examine how the integration of railguns and 50 caliber machine guns with the aforementioned firing trap will lead to an unavoidable attack on the UFO. The key to this is the use of AI to predict the UFOs, escape paths, and adjust the firing trajectory accordingly. The AI system would take into account the UFO's speed, altitude, and direction, using this information to determine the most likely escape routes. By continuously monitoring the UFO's movements and adjusting the railgun and 50 caliber machine gun positions, the UFO would be forced into a tunnel or cone of fire that it cannot escape. This approach would allow for a multi-layered defense with railguns and machine guns working in concert with each other and with the missile system. The railguns and machine guns would provide a constant barrage of fire, reducing the UFO's options for escape. This would increase the chances of a hit by either system, making it impossible for the UFO to evade all of the attacks. In the event that a hit is not achieved by either the rail guns or the 50 caliber machine guns, the missile system would be used as a last resort. Though the missile system is the least likely to achieve a hit due to its larger size, its use would further force the UFO into the other ordinances, increasing the chances of a successful hit. Russian conclusion: the combination of AI, railguns, 50 caliber machine guns, and missiles provides a comprehensive and highly effective defense against UFOs. By forcing the UFO into a tunnel or cone of fire, it becomes impossible for the UFO to escape. It increases the chances of a successful hit by either the railguns, machine guns, or missiles. This approach is a crucial step in ensuring the safety and security of our planet against any potential extraterrestrial threat.